quantum mechanics is the physics that describes the smallest things in the universe. So naturally, to really understand the basics and how quantum mechanics came to be, we have to start looking at very small things in the universe, and that starts with the atom, which was at one point thought to be the smallest thing in the universe. The word atom, atom, comes from the Greek word atomos, meaning indivisible, and that is exactly what people thought atoms were. In fact, the first scientist that really started focusing on atoms, although this concept, a fundamental particle that made up everything, had existed for thousands of years, the chemist John Dalton really brought this idea to the forefront of science. And he said that there was this atom, there are different types of atoms that make up the different elements that we have observed, and that atoms are small, indivisible, and neutral. Now, this was all good, but eventually we found out that that is not true, as hopefully you know. One of the next discoveries that really shook up this model was from a scientist, J.J. Thomson, who discovered a small electrically charged particle, and he called this the electron. Now, the electron is a negatively charged particle. So, J.J. Thomson discovered the electron, which is E minus because it is a negatively charged particle. And what J.J. Thomson came up with for atoms was not that they were indivisible particles, but he came up with what is called the plum pudding model. And so the plum pudding model is you have some kind of weird positive, something. This is all positive, so if I were to fill this in, he did not really, I don't think really said anything about what the shape of this was, so it's often drawn as just like a goo. And this is all positive. It's all positive. Okay? I don't want to draw that in there just so you can see that this whole thing, it's just a giant positive area. And then it was sprinkled with these negatively charged electrons around it. And this came to be known as the plum pudding model because I guess it sort of looked like plum pudding. That was, I guess, a very popular dessert back then. So you would have a sort of a pudding with these plums in it. So that was J.J. Thomson's model for the atom, where you have a neutral goo, and then you have the electrons, the small negatively charged electrons that J.J. Thomson had discovered. The next experiment that really shook up how we thought of atoms was from a scientist named Ernest Rutherford, who is a very famous scientist. And what he did, he found these particles called alpha particles. And what he did was he shot alpha particles at a thin gold foil. And I actually have a simulation from fat.colorado.edu, the link will be in the description, of this experiment. So let's look at this. So this is J.J. Thomson's plum pudding model, as I just showed you. And what he did is, and this is the results, this is the results of shooting the alpha particles at the gold foil, as you can see on the left side of the screen, if the plum pudding model was correct. So this is what would have happened. These alpha particles, which are small positively charged particles, because sort of overall it was all neutral, the alpha particles should have just gone straight through, because they were so small. This is what should have happened if the plum pudding model was correct. However, that's not what Ernest Rutherford discovered. What he discovered was something that looked like this. Shot these alpha particles, and many went straight through, but as you will see, there were some that deflected. Some went straight back, right? Some deflected at other angles, and he measured these angles. And if you change the energy of the alpha particles, higher energy, the more sort of that just shot straight through, lower energy, so it would have a lot of deflection. So this is an interesting thing, and right, this was a thin gold foil, and now this diagram for the experiment sort of shows what Rutherford determined, where he said that, well, this couldn't be uniform because otherwise all the electrons would be, all the alpha particles would be doing the same thing. They'd either all go through or all deflect for some reason if there was something else going on. But no, most of the alpha particles, especially if you have it at a higher energy, go straight through. It's just there are a few that will deflect. Every so often they will deflect. And what he determined was an atom is mostly just space. But at the center of an atom, there is a small little positive bit, and he called this the nucleus. Rutherford determined that this is how an atom actually looks. He said you have a nucleus in the center, and it's actually very, very small, but I'm just drawing it sort of so I can write the whole word. Actually, I'll just write it like this. So the nucleus is a small dot, and then you have the electrons just sort of floating around here. And I don't know exactly what Rutherford initially thought about the electrons, but the electrons were handled by another scientist named Niels Bohr, but we will get to that in a second. So the first thing I want to talk about is sort of what we learned from there, because there were some new particles discovered, and they actually found out that Rutherford's nucleus was not a single particle, but was actually made up of a bunch of different particles called protons and neutrons. And the proton has a positive charge, the neutron has a neutral charge. And the nucleus is just made up of protons and neutrons. And so you have, in an atom, you've got protons, neutrons, and electrons. And the identity of the atom, as we'll talk about, there are different types of atoms. You can have hydrogen, helium, lithium, beryllium. You could have other atoms like gold and iron. Those atoms are all defined by their number of protons. So hydrogen has 1 proton, helium has 2, lithium has 3, beryllium has 4, on and on. And then it has electrons. Now, if it's a neutral atom, the proton has a positive charge, and an electron has a negative charge, but the same magnitude of charge. So in a neutral atom, if all the charges add up to 0, you'll have the same number of protons and neutrons. And that actually allows us to have something called ions, which we won't be talking about much in this course, but an ion is just when you have different numbers of protons and electrons, so that there is an overall charge to the atom. And the other thing you can have is, I haven't talked about what the neutrons do, and the neutrons are a little bit more complicated. They often will have to do with how stable the atom is, but some atoms can have different numbers of neutrons in the nucleus and still, exist. And those are called isotopes, when you can have different numbers of neutrons but still be the same atom. So that's just a little bit of atomic terminology, but it won't be too important. Okay, so next is Niels Bohr, who said that, well, we have this nucleus from Rutherford, made up of protons and neutrons. And then you have electrons. They're not just sort of around it, they're actually in orbits. So you'd have electrons in orbits. And in fact, he came up with an equation about these orbits, and we'll talk about that in a few videos. But this was called a planetary model for obvious reasons, just like the planets orbiting around the sun. And this was the Bohr model, also known as the planetary model. Now, it turns out this is not correct. In fact, the electrons are not in fixed orbits, and in quantum mechanics, we will show, and this is one of the things we will show by the end of this course, is that the electrons actually aren't going in an orbit, they're actually in a probability cloud, right? So if you have the nucleus here, so this is a Bohr model, but the quantum model, which is what's actually going on, is we'll have a probability cloud, and there's a certain probability, right? If we measure that, we'll find the electron somewhere, in this cloud, and there can be, could be more likely to be found out here or more likely to be found in here, and we'll talk all about that and how we can figure those things out. So the quantum model of the atom is that you have a nucleus and then you have an electron probability cloud of where you're likely to find the electron and where you're not likely to find the electron. So hopefully that makes sense. That's just an overview of how we look at the atom in quantum mechanics. And in the next video, we'll be talking a little bit about atomic spectra, which is our next really big piece of evidence for quantum mechanics.